Okay, the last method we're going to look at from the math class is the random method. Now, okay, it says right here that the random method returns a double in the range 0.0, 1.0. Notice how they used a bracket on the left and a parenthesis on the right. Maybe you remember from your math class, that means that it's inclusive of 0, yet exclusive of 1. Okay, so in other words, it could possibly return 0, but it could never return 1.0. Okay, so the way that this method was written, it's going to return a double value between 0 and 1, but it could never return 0. Sorry, it could never return 1, but it could return 0. Now, I've never seen it return 0. The odds of it are, I don't know, about 1 in 10 million or so, maybe less, but in theory it could. So let's try this out. Math.random. Okay, we just put a parentheses on there. This is a method. However, like I was saying earlier, this is what we call a parameterless method. You don't provide any extra information to use this method. Since it's static, I just reference the class that the method is in, and then I provide the method name. I'm not providing a string because I'm not applying this to a string. I'm not applying this to anything. Okay, you probably didn't get the same answer as me, but that's fine. This is a random number. Now that would be million, billion, trillion. So yeah, the chances of you getting 0, I think, are about 1 in quadrillion or something crazy. Okay, so it could return 0, but it's real unlikely to. So, okay, we say that the range of this method is 0 less than or equal to the number, but less than 1. Okay, so like I said, 0 is a possibility, 1 is not. Well, that's kind of just a fixed range. Like what if we wanted something different? What if, for instance, what if we wanted a range of, say, 0 up to and including 10? Okay, how could we do that? Well, the good news is we don't have to really change much. We'll just take this and we'll multiply it by 10. Okay, and then you think about it, like 10 times 0 is 0. So we still have the possibility of 0 on the left end, and 1 times 10 is 10. So I can't get 10, but in theory I should get like 9.999 or something, really, really, really close to 10. Okay, I mean, there's so many decimals there. We're willing to ignore if the last one's missing, or we don't have to get too worried about that. Okay, so let's see what we get for our random numbers this time. Okay, completely different. Turned out I got a number that was pretty small, 0.38, but I bet if I run this again, okay, now I got 6.62. Again, I could keep doing this, and I shouldn't see any numbers out of that 0 to 10 range. All right. Very often, like a real common problem would be to randomly simulate the roll of a die. Okay, like a 6-sided die. So this is a real common issue we see. Okay, maybe we're making a program like a board game, and we want to roll some dice. All right. So if you're rolling dice, you're looking for integer values, not doubles, all right, from 1 to 6, okay? So, or anything in between. All right, so I want to get integer values back from 1 to 6. How am I going to use the Math.random function to produce those values? Well, this gets a little bit tricky. Now, something I'd probably want to consider is a typecast. Okay, because this gives double and I want int. Now, this is really weird though. If you do a typecast like I've got set up here, you're guaranteed to get the same answer every time. I'll prove it to you. I'm going to do this about, I don't know, 7 or 8 times, okay? And I should get 0 every single time, which doesn't seem very random. Let's see if we do. Okay, I got 0 every single time. That's not good. So that's not random. Why am I getting 0? Okay, well, because when I did a typecast on numbers that exist between 0 and 1, well, just think about what that does, right? A typecast truncates the decimal. It's just gone. Everything's gone. So if it was 0.2, 0.8, 0.76, the decimal disappears, you just get 0. So I got 0 every single time. Well, what if I put here a times 6? Makes sense, right? Because I'm rolling the die, and I'm trying to have any of 6 numbers return. Well, you still got to be careful. You might be surprised by this, but I'm going to get 0 every single time again. Okay, so let's see. Okay, let's see if I get 0 every single time. Okay, screen full of zeros. Now I multiplied by 6. Why am I still getting 0? Well, look at the order, right? Remember, Java reads strictly from left to right. So since Java is reading strictly from left to right, what takes place first? The typecast. The typecast turns the random number into 0 before the 6 is multiplied. That's no good. I don't want to have 0 times 6. I was hoping to get a number between 0 and 1 to multiply by 6 to get closer to my die. So what I could do is, okay, encase this operation here inside of parentheses. Now what that's going to do, that's going to ensure that the multiplication takes first and not the typecast. Okay, well let's see what we get now. Now again, we're trying to simulate the roll of a 6-sided die which could produce any number from 1 to 6. Okay, so let's see what we get this time. All right, I run my program. All right, I got 3, 5, 4, 5, 3, 0. Now, these look pretty random, but I don't think you can roll a 0 when you're rolling a 6-sided die, right? Our options are 1 through 6. So how did we get 0? We multiplied by 6, but remember, the range was initially 0 to 1. So when you multiply by 6, you can think of it kind of like this. I changed the range from 0 up to and including 5.99999, kind of like that, okay? Because remember, this is kind of like you're saying less than 6. So less than 6 is like 5.99999. Now, when you did a typecast on that, okay, so when you did a typecast on 5.999, that became 5 on the right, but it stayed 0 on the left. All right, so we're going to make one more adjustment here. We're going to put in a +1 on all of these, okay? And what that +1 is going to do is it's going to shift our range up 1 unit. So instead of being 0 up to 5.9999, now it's 1 up to 6.99999, okay? Now, if you do a typecast on that, because remember, I still have that integer typecast over here, that typecast should truncate the 0.9s off of the 6, leaving me the perfect range, any integer from 1 to 6. So when I run the program, I don't know what I'm going to get, but what I'm saying is I'm not going to get any numbers that aren't 1, 2, 3, 4, 5, or 6. So let's make sure that that happens. Okay, so look at the numbers I got. They're all in that 1 to 6 range. I didn't actually roll any 6s. Let me try it again because I want to make sure that this can produce a 6, and it did now. So now I feel pretty good. I don't see any 0s. I don't see any 7s. And I think I've seen every possibility at this point. So it can produce 1s, it can produce 6s, and so on. Okay, and that's what we're looking for. This is a real good lesson. This is something you might see on your AP test, or or some variation of this. But that's how we can work with the Math.random function to produce the desired range of a simulation that we want.